In this video, we're going to learn how to calculate the expected value, the variance, and the standard deviation for a discrete random variable. So we already learned how to calculate measures of central tendency and dispersion in Chapter 3 for a variable that we have. And so it's actually quite similar for a discrete random variable. So the expected value, that's just a fancy term for the mean. So when we're calculating the mean, what it is the expected value is a weighted average, now note that's very important, of the values of the random variable where the weights are the probabilities. So I know that sounds like a mouthful, and it is, but let's just look at this, break this down. So here's the actual equation for the expected value, right? The expected value of x, that's how that's read, equals the mean, which is mu, and it's equal to the sum of your values, right, for the random variable x, right, those are the values, times by the weights. But the weights are equal to the probability. So f of x, that's how that's read, that represents the probabilities of the values of x. So really what we're doing is it's a weighted average. So let's look at the equation for a weighted average, or the weighted mean, which we learned about back in Chapter 3. So if you remember, for an example, say you're taking a course and your instructor uses a weighted average. So it might be the case where your exam is worth 20% of your grade, a final project's worth 50% of your grade, and so on. So to calculate your weighted average, what you do is you take the values that you got, your scores, which are x, and you'd multiply them by their respective weights. So whatever your score for your exam, you'd multiply it by 20%. The score for your final project, you'd multiply it by 50%. And whatever those values come to, you'd sum them, and then you divide it by the sum of the weights, and that would give you your weighted average. So it's actually what's happening here in this equation. So if you look at this, we have, right up here, you're taking your values of x and you're multiplying it by the weights, right? X and multiplying by the weights. But remember, the weights are the probabilities. So the function of x, that's the probability. So that's all you're doing. You're taking your values of x for the random variable, you're multiplying it by the weights, which are the probabilities, and then you're summing them together. So you might be thinking, well, you're missing a part. Why aren't you dividing by the sum of the weights? Well, remember, when we calculated probabilities, from our last video, we learned that probabilities could be determined by relative frequencies. And we learned that relative frequencies, right, if you add them together, they sum to what? They sum to 1. So really, in essence, you're just dividing by the sum of the weights, which comes to 1. So you're just dividing by 1. So we don't write it there, but it's implied. So that's where this equation comes from. So then when we think about the variance and the standard deviation of a random variable, it's really just telling us about the spread or the variability or the dispersion of the data. Once we calculate the variance, we can take the square root of it, which will give us the standard deviation. So the variance, right, it's a weighted average, and it's a weighted average of the squared deviations of a random variable from its mean, where the weights are the probabilities. So again, right, here's the formula for variance for random, discrete random variable. So if you remember the formula for variance, it's actually quite similar, right? So the variance is telling us the average distance that values are different from, or how far they are from the mean. So that's really what it's giving us. It's saying, okay, here we're taking for each of your values, how far is it from, right, the mean? And remember, we square it. Do you remember why we square it? Right, because sometimes when we add these, the sum of the differences, right, the square, the differences from the values from the mean, they sum to 0, so we square them, right? We take those, right, and then what we're going to do is we're going to multiply them by the probabilities, because remember, it's a weighted average. So, right, what are the weights? They're the probabilities. So by doing this, by summing these, right, it's going to tell us the variance. And if we take the square root of the variance of sigma squared, it will give us the standard deviation. So we're actually going to go through an example to show how to do this in the next video.